And the next thing we're going to talk about in 2.6 is the different types of asymptotes that you can have in a graph. The first one is the vertical asymptote. It's related to your domain in a lot of ways. We say the vertical asymptote is the line x equals a, is the vertical asymptote of a graph of the function f if f of x increases or decreases without bound as x approaches a. A graph may have several vertical asymptotes, but the graph will never intersect the vertical asymptotes. Okay, the next handout that I'm going to show you here is something that you can find in your book. If you look at your e-book in section 2.6, you would see this graph giving you some examples of what vertical asymptotes are. They are vertical lines that your graph will approach but will not touch, may skip over, but will not cross. Okay, an example of a function that has vertical asymptotes is your reciprocal function that we just talked about. The parent graph has a vertical asymptote of x equals 0. So it's anywhere where the function would be undefined, okay, but it is a vertical line, so it's listed as x equal to a number, okay. To locate vertical asymptotes, to find those, if you have a function, it says if you have the rational function in which p of x and q of x have no common factors and a is a 0 of q of x, the denominator, then x equals a is a vertical asymptote of the graph. Okay, so as far as the examples that you'll have to work out, is, like I said, very similar to how you were finding the domain. You do not want your denominator to be 0. So you just set the denominator. Actually, in this case, we're going to just leave it equal to 0. So x equals -5 would be the value where this function would be undefined, okay, in the domain. So that is your vertical asymptote. That vertical line, x equals -5. The graph would approach that line, but it would never cross it. It would either increase or decrease without bound. Now, if you look at the next example, you may have more than one example of a vertical asymptote. So if I set this equal to 0, x squared plus 1 equals 0, it will not factor, but if I take the square root of both sides, I'm going to get plus or minus I. Okay, just like what we talked about earlier, as far as getting an imaginary number, this would mean that we would not have a vertical asymptote at this value because it's not a real number. Okay, so we'd say because it's not a real 0, there are no vertical asymptotes for this graph. The other type of asymptote you can have is one called a horizontal. Okay, so horizontal lines are always y equal to a constant. So we say it's the line y equals b is the horizontal asymptote of the graph of the function of f if f of x approaches b as x increases or decreases without bound. Now, a horizontal asymptote is different from a vertical in that a graph can only have at most one horizontal asymptote, and a graph may cross the horizontal asymptote. Okay, again, if you look in your e-book, if you wanted to look at these graphs in section 2.6, you would find this diagram showing you some examples of what horizontal asymptotes are. This is an example of a graph where it approaches the horizontal line but doesn't cross it. So this is a horizontal asymptote. Same thing here. But this graph, if you notice, it actually comes down, crosses over, but kind of the end behavior is that it approaches that horizontal line but never crosses it again. Okay, but it may intersect it one or more times and then kind of follow that pattern of just approaching it but not crossing it. Okay, finding a horizontal asymptote is very different than finding the vertical. Okay, so the notes that I'm going to put on here, you may need to write down as far as how you can find a horizontal asymptote. It depends on your equation. Okay. We say that if we have a rational function, I'm going to let n be the exponent of the leading coefficient in the numerator, and m is going to be the exponent of the leading coefficient in the denominator. Okay, so this would be, something if I had like a to the n over, we'll say b to the m. Okay, that's just a real simplified version here. But this is my numerator my exponent in the numerator, my exponent in the denominator. And that's what I'm comparing. Okay, so first I would say if n is less than m, if the numerator degree is less than the denominator, then the x-axis, or y equals 0, is the horizontal asymptote. Okay. The other choice is if those degrees are equal. If the degree of the numerator is equal to the degree of the denominator, then we say that the line y equals a sub n over b sub m is the horizontal asymptote. And that's just dealing with the coefficients, and I'll show you an example like this in just a few minutes. Okay, and the third choice is if n is greater than m. If the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. Okay, so the next few examples will be one of each type. What can happen in each of these three cases?